Molar mass calculations are just one step in a much longer problem we're going to learn to do. But in doing that problem, we're also going to have to be able to write what are called molar ratios. And molar ratios require that you have a balanced chemical equation. Okay, let me stop this right here because y'all don't want to look at that. Okay, Goose Man over here was watching my video on my other computer. Okay. Shh. What is it? Is it still playing?
No. Keep going. This is good.
No. All right, here we go.
Is that your plan?
No, it's just don't worry about it right now. You'll get a chance to see it. Okay.
What music do you listen to?
Can we do this first? Really? Let's do this first. Okay. All right. So, in order to write molar ratios, you've got to have a balanced chemical equation. In order to write molar ratios, you've got to have a balanced chemical equation. So all this stuff in this unit, starting with Unit 2, we're starting to learn to write formulas, and then putting the formulas into equations and balancing equations. Now we're going to actually put them into another process in this stoichiometry process. And it's only called stoichiometry when you have to have a balanced equation. Okay, and that's where this molar ratio comes into play. So let's start with something fairly simple. Let's say I've got magnesium hydroxide, and we'll leave that in a solid form to start. And I'm going to put that with hydrochloric acid. Okay, so I could start out with a problem like this and ask you to do all kinds of work with this. Okay, we're going to keep it simple for the moment. So what I want to do first is predict the products. Okay, the rules for predicting the products. You first have to figure out what kind of equation it is. Okay, this is a two-part formula here. Ionic formulas are always in two parts. You know it's ionic because it's a polyatomic ion right here. You know this is in two parts because it's an acid. Acids are always in two parts. You've got the hydrogen and the other part, whatever the anion is. Okay? Two-part formulas. The most likely kind of equation we're going to have is double replacement. Okay? Where the A part goes with the D part and the C part goes with the B part. Okay? So then magnesium is going to join up with the chlorine. We're just going to put those symbols together to start. The hydrogen is going to go with the hydroxide. Right? Remember, subscripts don't travel unless they're part of a polyatomic ion. This 2 is outside the parentheses, which means it's not part of the polyatomic ion. The polyatomic ion is OH. And if you look it up on your common ions list, it'll have OH, not OH in a parentheses and a 2 outside. Okay? All right. That's just putting together the formulas. That's all we're doing right now. We're not balancing the formulas yet. We still have to do that, and you have to balance formulas before you can balance equations. So first thing we want to do is to figure out what physical states do we have over here, because that's going to tell us if we have a driving force. Well, you probably already have guessed, because we've done this enough to know, that this is water, and it's going to be a liquid, and there's no heat here. Not enough heat anyway to make it into steam, so we're forming water. That's one of our three driving forces. Formation of a solid, formation of a gas, or formation of water. This is one of our three driving forces, so we have a driving force. The equation is going to go forward, we're ready to do everything else. If the equation wouldn't go forward, if we didn't have a driving force, then we just write NR, and we'd be done. Okay? All right. So let's see. Let's go ahead and balance this formula then. We need to look where to find out how to balance these two parts. Oxidation numbers. I'd look on the periodic table of oxidation numbers, and I'd see if I looked that magnesium has a 2+ charge and chlorine has a 1 negative. So how many of each of those do I need?
We need 2 chlorines.
2 chlorines, okay. Now we want to know its physical state. What physical state am I going to write for a magnesium chloride?
Aqueous.
Okay, and how did you figure out it was aqueous? Solubility rules, and you look at where it says chlorides, and it says chlorides are mostly soluble, so if there's water it will be aqueous. Mostly soluble, the exceptions are silver, lead, and mercury 2, and magnesium is not one of those. So this must be aqueous. Okay? So we're going to write aqueous. Now that we balance the equations, now that we balance the formulas, we're ready to balance the equation. Okay? Yes, you're right. There's a plus sign there. Okay? So now we want to write an atom inventory. Mg, O, H, and Cl. Make our grid or our spreadsheet, whatever you'd like to call it. Fine with me. Atom inventory. Remember, the line goes under the arrow because you're going to keep everything on this side of the line over on this side and everything on this side of the line over on this side. So we count everything up. We've got 1 magnesium. This 2 here means I have 2 hydroxides. And each hydroxide has 1 oxygen. So overall then I have 2 oxygens here. And I'll put 2 down there. The 2 also means I have 2 hydrogens, but I also have a hydrogen over here. So I have a total of 3 hydrogens. And there's no subscript or coefficient or anything around this chlorine, so that's a 1. Over on the other side, I've got 1 magnesium, only 1 oxygen, 2 hydrogens, and 2 chlorines. What I want to do now that the formulas are all balanced, I cannot touch this. Okay? I cannot touch the subscripts. I must only use coefficients, big numbers out in front, to balance the equation. Okay? So let's see. In order to get this balanced, I'm going to say oxygen for last, hydrogen for next to last, start with chlorine. So I'm going to need to get 2 chlorines. I need a coefficient 2 here. That'll give me 2 chlorines, but it also changes the number of hydrogens. Okay. Remember, this 2 outside means I have 2 hydroxides. Therefore, I've got 2 hydrogens plus the 2 hydrogens this coefficient made over here. So that's a total of 4 hydrogens. Okay? Now that we've got magnesium and chlorine balanced, and we're saving oxygen for last, we're ready to try to balance the hydrogen. I've got 4 on the left, 2 on the right. I need a 2 in front of the water, which multiplies the 2 existing hydrogens by 2. So that gives me 4 hydrogens, but it also gives me 2 oxygens, and the equation's balanced. All right, but that's just the place to start. Now we're ready to write a molar ratio. The fact that we have these coefficients in front of all these species allows us to write a proper molar ratio. So let's say, for example, that I have 3.75 moles of magnesium hydroxide, and I want to know how many moles of hydrochloric acid are needed to fully react with the magnesium hydroxide. Okay. Just a reminder now, in this unit, or let me go back. In Unit 1, I gave you in the problem enough information to figure out what your conversion or equality statement was going to be. Okay? In this unit, you're having to figure out your own equality statements. However, molar ratios don't allow you to write a true equality statement. So that's not required here. What's required here is the balance equation. Okay? All right. So the first thing I want to do is to write my starting amount over 1. And if you read the problem, you should be able to interpret the problem to show you that that's the starting amount. So we're going to write 3.75 moles of magnesium hydroxide. And we're going to put that over 1. All right? What we need now is a molar ratio. We're trying to go from moles of one thing to moles of another. Okay? We're going from moles of one thing here to moles of another. moles of magnesium hydroxide to moles of hydrochloric acid. Okay? So to do that, then we're going to use the molar ratio that is implied in the balanced equation. Now, you can look at these coefficients as meaning 1 formula unit of this and 2 formula units of this. But if you'll remember, how many of these formula units in a mole? Starts with an A.
Apple.
Avogadro's number.
Avogadro's number.
There's 6.02 times 10 to the 23rd of these formula units in 1 mole of that. Okay? So if for each of these moles, there's 6.02 times 10 to the 23rd formula units of this, right? And I have 2 of them. So that's 12.04 times 10 to the 23rd, right?
Yeah.
Those are really big numbers to have to deal with, wouldn't it? Okay, but it'd be a lot easier if I just used moles instead of the big old, number of particles number, right?
Yeah.
So all I'm doing then is mentally converting these from individual formula units to moles of those. Because all I care about is the ratio. If one of these can be put over 2 of these, or 2 of these can be put over 1 of those, then 1 mole of those, which is all times Avogadro's number, all we're doing is multiplying, we still got the same ratio, correct? It's just like 1/2 is the same as 2/4, is the same as 3/6, right? That makes sense? All we're doing is multiplying to get there. Okay, so when we write 1 mole, we're just multiplying by Avogadro's number to get there. Does that make sense to everybody? Okay. What does that mean? 36. Oh, okay, I got it. Okay. So what I want to do is to match the starting units and species, and that's going to be 1 mole of this species. Okay? 1 mole of magnesium hydroxide. Okay? When I say match, I mean I'm going to put on the bottom of this conversion factor in this case.
So you can cancel out.
So I can cancel out. And since what I'm trying to get to is moles of hydrochloric acid, the 2 moles represented here need to go on the top. 2 moles of HCl goes on the top. And we're going to
Cross out.
cancel as we go. Okay? And when we get done, we're going to have the moles of hydrochloric acid I'm looking for. All right? And I believe that'll come out to be, let's see, 7.50. Is that right? Is that what your calculator says? Okay, well that brings us to another thing we need to talk about. How many significant digits am I supposed to have at the end of this problem?
1, 3,
3 significant digits. Okay? The least number of significant digits that matter is right here. These are counting numbers. I counted them 1, 2, and 1.
Oh, yeah.
They don't matter. This is what matters. This is a measured or calculated number. Okay? And a good guess that it's a measured or calculated number is the fact that there's a decimal place there. Okay? Not always true, but almost always true. Okay? So I really need another digit here. So I could just write this. Or I could have just written it here to start with because I can see that I need it. Okay?
Okay.
So your calculator doesn't tell you everything, folks. It's a wonderful, wonderful tool. But it has some shortcomings. Okay? The calculator can do calculations for you much faster than you and I can. However, you still have to think. I'm sorry. Just have to.